Okay, we got notes 3.2, we got polynomial operations. So, the steps, right? If you add or subtract, you gotta, well, first you gotta figure out if you're add, subtracting, or multiplying. If you're adding or subtracting, okay, you go to the left here, and you distribute that +1 or that -1 to that back parentheses, and then we combine like terms as normal. If you're multiplying, okay, this is where it gets a little bit crazy, but you're still distributing, but you're going to distribute each piece in the front parentheses to the back parentheses one at a time. And then, once again, combine like terms. Okay? So if you need a pause to write this, please do. And if you don't, absolutely move on to the next one. So first you need to identify in this problem here if you are adding, subtracting, or multiplying. Now, if I look right here, I see that we're adding because I got a plus sign between my parentheses. So that means I'm going to have this +1 to distribute to everybody in the back. And when I do that, it becomes plus 1x squared minus 2 minus 8x to the 4th. So we had distributed +1 to the back parentheses. Now, the rest of this does not get distributed to because it didn't have that +1 in front of it. So what's going to happen is this all just comes down, and you get to drop the parentheses since we didn't have to do any math with it. We didn't have to multiply. All right, next up is our favorite. We are going to combine like terms, and we're going to go one piece at a time. So I got this 8. The other like term here is this -2, and that is 6. Next up, I got 3x squared, so I'm looking for another piece that's got x squared, which is right here, and that's the only one. So that gives me 4x squared. And then last but not least, we have this -8x to the 4th. There are no other pieces with x to the 4th, so we are done. There is another way where you have to write this in highest power order, but you know what? For my class, for my students, we are going to be happy with this. Or if you want to write it in that particular order, -8x to the 4th will go first, plus 4x squared will go second, and then plus 6 will go last. Okay? Both of these are good answers. If you leave it undone, that's fine. If you put it in order, I'm super happy for you. All right, this next one here, I look to see what we're doing, and in this case, I see we are subtracting in between these two, so that means I got this -1 to distribute to the back parentheses, so this becomes -2 minus 2a to the 3rd minus 4a to the 2nd when I distribute that -1. This stuff up front here, oops, I hit my camera. This stuff up front here, there was no distributing that happened, so I have everything staying the same, and I can drop the parentheses since I didn't have to deal with any distributing. Now, if you write that little love note here, all we did was distribute that -1 to the back parentheses. Okay, and next up, always after distributing, you always got to check for combining like terms. It'll always be this way. It's a very good practice to have. So I always like to start with my first piece. So I got 6a to the 2nd power. I need to find another piece that has a to the 2nd power. And I got this piece over here. So when I combine this, this becomes 2a to the 2nd power. Next up, I'm going to have this constant of 4 here. And another constant is right here, this -2. So 4 minus 2 is a +2 still. So I got to make sure I put +2. Next up, I got this 7a to the 3rd. Another piece with a to the 3rd is this -2. So this gives me 5a to the 3rd. And I will take this as an answer, or if you want to put it in power order, it would be 5a to the 3rd plus 2a to the 2nd plus 2, going from highest exponent to lowest exponent. All right, number next. Here, I don't see any symbols in between, so whenever you see that, you get to know or should know that this is multiplying. And this is where it's going to get crazy, so you need to make sure you're paying attention. So we're going to distribute 2r to the back. So I got this 2r, I'm going to distribute. 2r times 6r becomes 12 r squared. Why does this become r squared? Because when you have an r times another r, you just add up how many r's there are. So r to the, this is an exponent thing, right? If you have r to the first power times r to the first power, it becomes r to the second power. So you got to kind of remember that from freshman year for my students. But when you just do 2r times negative 5, you just multiply the big numbers and you get negative 10r. Then we are going to distribute the 5 to the back. So we got 5 times 6r is 30r. Again, that r stays how it is because there wasn't another r. And then we got 5 times negative 5, which is negative 25. And now we combine like terms. And we get, this is 20r. The rest of it didn't change. There was no other like terms for 12r squared or minus 25. So this is a good answer, and it's already in power order, so go for us. Last one here. We got 3 pieces up front and 2 pieces in the back parentheses. And once again, we don't have any symbol in between, so we are going to, this is technically multiplying, okay, because we don't see adding or subtracting symbol in between. So 1 piece at a time. I'm going to start with that front piece. I'm going to distribute 3x squared to the back. All right, so I have 3x squared times 3x. Well, 3 times 3 is 9. This has 2 x's. This has 1 x here, so that means there are 3 x's altogether. All right, this is that, again, that exponent rule. I think the name is called the product rule, but it's been a minute. Then I got 3x squared times 4 is 12x squared. And that's the end of that one. Now I'm going to distribute negative 2x to the back. And now I got to do that one. So negative 2x times 3x is negative 6x squared because there was 2 x's. Negative 2x times 4 is negative 8x. No x's to change. And then last but not least, I have this negative 4, so I'm going to distribute negative 4 to the back. I'm running out of space. So negative 4 times 3x is negative 12. The x's don't change because there was just 1. And then you got negative 4 times 4 is negative 16. And then now from here, we are done. So now we can combine like terms. 9x to the third power is the only one. We got 12x squared and minus 6x squared, so these are like terms, and together that makes 6x squared. We got negative 8x and minus 12x, together that makes negative 20x. And then last but not least is this negative 16, and everything is already in order for us, so that's super duper. And that's the end of this video. I hope you enjoyed it. Sorry for the whistling and the tapping of students at my door.